The law was first enunciated by Prevost. According to this law, when two bodies are brought in thermal contact, they exchange heat irrespective, irrespective of their temperature. For example, consider two bodies A and B which are in thermal contact. According to this law, the body A, which is at higher temperature, will lose more heat and give it to B, whereas the body B, which is lower temperature, will lose less heat and give it to A. This means A will lose more heat and gain less, whereas B will gain more heat and lose less. Thus, there is a net loss of heat from A and net gain by B. If there is no dissipation of heat and also no gain of heat from the surrounding, that is, if A and B from an insulated system in which there is heat interaction only between A and B, then according to the law of conservation of energy, the branch of heat which is concerned with the measurement of heat is called calorimeter. A calorimeter consists of a copper vessel which is enclosed inside a wooden box. The space between these two is filled with insulating materials like paper, straw, wooden fittings, rubber, foam, etc. The calorimeter the calorimeter is so designed as to minimize all types of heat losses. The top of the calorimeter is closed by a wooden lid which consists of two holes through which a thermometer and a stirrer are allowed to pass tightly. To measure the specific heat capacity of a solid substance like a metal piece, the following procedure is adopted. First of all, the mass of the calorimeter with stirrer is measured with a physical balance. After that, nearly two-thirds of the calorimeter is filled with water. The mass of calorimeter with water is measured. The room temperature of the calorimeter with water is found by the thermometer. The metal piece is heated in a steam bath called hypsometer till it attains the temperature of the steam generated at atmospheric pressure. It is then gently dropped into the water contained in the calorimeter, which is now covered with the lid. The temperature of water begins to rise. The water is stirred so as to keep its temperature uniform throughout. The process of stirring is continued till the thermometer fitted in the lid of the calorimeter attains a final steady temperature. This temperature is noted. The calorimeter with the water and metal piece forming mixture is again weighed. The method adopted to determine the specific heat capacity of a solid can be used for the determination of a specific heat capacity of a liquid. Here the calorimeter is filled partially with the given liquid. Instead of water, a metal piece of a specific heat capacity is heated in a hypsometer to a constant temperature and then dropped into the calorimeter containing the liquid. In this case, the hot metal pieces loses heat, whereas the liquid and the calorimeter gain heat. Using the law of heat exchange, the specific heat capacity of the liquid can be calculated. In general, When heat is added to a body, its temperature rises. For example, when water is heated, its temperature rises. If we placed a ball of water in the sun for some time, its temperature rises because it absorbed heat radiant from the sun. But in certain situations, even with the absorption of heat, temperature does not rise. This happens when the body changes its phase from solid to liquid or from liquid to gas, etc. During the change of phase or state, the temperature of the body remains constant. With reference to the constancy of temperature, the added heat is called the latent heat or hidden heat. Latent means hidden. All solid substances require latent heat for fusing or melting. The latent heat of fusion depends on the nature of the substance. Here we give a table melting and boiling points of certain substances. Every substance changes its states from solid to liquid at a particular temperature at normal pressure. During the change of state, the temperature remains constant. 1 kilogram of every solid substance needs a definite quantity of heat energy to change its state from solid to liquid. It is called the latent heat of fusion of the substance. Mostly substances show an increase in their volumes on melting, for example wax, ghee, while a few substances show decrease in their volumes on melting, for example ice. Melting points of those substances which shows decreases in their volumes on melting are lowered with the increasing of pressure varies. Melting points of those substances which show an increasing their volumes and increase with increase of pressure. We now consider two cases referring the to latent heat. They are a latent heat of fusion of ice and B latent heat of vaporization of water. It is the amount of heat energy needed to melt 1 kg of ice at 0 degree completely to 1 kg of water at 0 degree. The experimental values of the latent heat of fusion of ice has been found to be. This also means if the 1 kg of water at 0 degrees completely frozen to ice, the same amount of heat energy will be given off from it.